Go. All right.
6-6.
All right, guys. Annalise, stay with me.
This is literally the first time I've
No,
done
that's
it.
not. I'm just. Don't get mad. All right, ready? Here we go. You are gonna compose functions today. What does that mean? You're gonna add functions. You're gonna subtract functions. You're gonna multiply functions. You're gonna divide functions. That's really what you're gonna do. Then you're gonna give me the domain. That's the x values that actually get answers. Okay, so what x values actually get answers, that's what you're going to do. Then you're going to evaluate, I wish it said composition functions, but compose functions. This is where we did this back in September. This is where we did f of g of x. It's a function inside a function. These are kind of weird, and you didn't, for the most part, you didn't really like these, but it's the second time around, so I'm thinking it should get better for you. But that's what you're doing today, okay? All right. Hang on. Getting there. Boom. Okay, here's where you're at. They're trying to tell you this. If you are going to add, subtract, multiply, divide functions, when they tell you to add f plus g of x, just write this down, or in your mind, think about it this way. F of x plus g of x is addition. Where subtraction would be f of x subtract what? G of x. You can think it through, or you can write it on paper like I just did, and then we'll plop the functions in just a second. This one is f of x, this is multiply, times g of x, and division is just going to be written like this. F of x divided by g. Now this is what we're going to do on this first page. Add, subtract, multiply, divide. We are also going to mention the domain, and now this is the part that students kind of get confused on. And it says right here, the domains of all these things, sum, difference, product, quotient, consist of x values that are in the domains of what? Both. So for you to tell me the domain in the end, after you add them, subtract them, divide them, you have to say what's ever in F, and it's in G also, that's the domain. And I'll help you in just a second. The only one that gets tricky up here is division. So maybe make a little star by it, I suppose. I don't know. It says also the domain of division, not quotient, functions does not contain any x value for which g of x is what? Zero. Why? Look where g of x is positioned. Where is it?
Denominator.
It's in the denominator, so you can't let the denominator ever be what? Zero. You can't divide by zero. You gotta remember that in the end, okay? Okay, let's go. It's not hard. It's just we gotta get through a few of them. Okay, first thing. We're gonna do what? We're gonna add the two functions. It says right here, take f plus g of x. Well, I would rewrite that, or at least I would think it differently. I would think it like this. If they want me to add, they just want me to add two functions. Just take f of x, add g of x. Well, look up here. F of x is what? 2x squared plus 8. So I'll write that down, and then what am I going to do to it?
Add x minus 3.
Add g of x, yeah. That's, yeah, you're right, John. X minus 3. So if I add the two functions together, I look for what? Like terms, common terms, okay. Well, here's an x squared term. I don't see any more of them. Here's an x term. I don't see any more of those. All I see are two constants that I could possibly add together. What are they? 5. And when you add the two functions, that's what you get. Good? Addition's pretty easy. Now subtraction gets a little different, okay? What'd you say?
Do I have to solve for them?
No, these are not equations. This is just take a function, add another function, and get the final function. So if I add this function to this function, bam, that's the answer.
So why does it say what is it?
Oh, that's what I'll get to that last, okay? Thank you. Okay, the next one is subtraction. Let's do it. F minus g of x, well, I would write it like this. That's how I'd write it, or that's how I'd think it. And then I'm going to write down f of x. F of x is 2x squared plus 8. Now I have to do what to it? Subtract what? X minus 3. Now be careful because you guys, you're subtracting a binomial. Guess what you need? Oh, okay. You guys, you're going to subtract this number. You're going to subtract this number. You need parentheses. You have to tell yourself, there's two numbers here that I need to subtract, and I need to do what with the negative sign?
Make it positive.
I can make it positive and then make everything else inside opposite. Or I can think of the negative as negative 1 times this. So I was hoping you would tell me to distribute the negative 1 through. So if you do that, what do you get here? Negative x. And that part you would have got right. The part you might have got wrong would have been right here. You might have forgot to change the negative 3 to what? Yeah, and that's why students will get subtraction wrong. They just don't run the minus sign through. Okay, final answer, 2x squared, take away x, plus 11 is right. Good? And good. Okay. Add, subtract. Which one's harder? I think subtraction is harder because you got to remember to run the negative through. Okay, this is the last thing we have to do. It's right here. Once you do this, give me what are their domains down here. So that just means what works, what numbers actually work in those. Well, for you to get that right, you're going to have to do this. In the very beginning of this whole problem, you need to state the domain of the first one and then state the domain of the second one. Now, I don't know what you guys remember about domain, but domain is the x values that get answers. You see this x here? You're going to do what? Square the x. Think of all the numbers there are. Either a number is positive, it's negative, or it's 0. Can you guys square positives and get answers? Yeah. Can you square the number 0? What's 0 times 0?
0.
Oh, you got an answer. Can you square negatives?
Yeah.
Yeah, so what can you square? Just about everything, right? All real numbers are in the domain. Every x gets an answer. What about this one? It says take a number, subtract 3. Positives, can you take 3 away from positives? Can you get an answer? Yeah. How about negatives? Yep. How about 0? Yep. Okay. Guess what? Domain is all reals. Okay. So once you know the domain of f and g, the domain of your answer, it says up here, and I think I read it to you. I think I did. It will be the x values that are in the domains of what? Both f and g. So basically, whatever f and g share are the domain of the answer. So what does this group and this group share? Yeah, everything. They share everything. Every number in here is in here. So guess what? The domain of your answer will be what? All reals. Same thing here because it's the same two groups. They share everything. The domain of your subtraction problem will be what? All real numbers. Okay? That's it. Now we're done. We added, we subtracted, we gave the domain of the answers, and now we move on. Okay, last two on this page. This one says f, what?
Times.
What's that mean? Times g. So take function f times the function g. Well, to me, I would think of it like this. And you don't have to write this on paper, but in your notes I'd write it. It just means, that means this. So take f of x.
So will we have to FOIL this?
Oh yeah, you're gonna have to do some foiling. That times what? X minus 2. Now John uses the word FOIL. FOIL really goes with binomial times binomial.
Distribute.
Yeah, that was the better word would be distribute, but you can say the word FOIL. I get what you mean. And I usually start with the binomial, and then I multiply it times the trinomial. So it's this, this, and this, right? You would get x cubed plus x squared minus what? 6x. Okay, are you done? No, you gotta do the negative 2, right? Times this. Negative 2x squared times this. And then finally this one, plus 12. And whenever you multiply, you look for like terms. So here's an x cubed term. Any more of them? Nope. X squared. I see this one and this one.
Negative x squared.
Yeah, that's negative 1x squared. Okay. Negative 1x squared. And then, you know, like, maybe I should just cross these out now so you don't look at them. Okay, what else?
Negative 6x.
Negative 6x and negative 2x.
Negative 8x.
Yep. And then those are gone. Plus 12. Right? See, it isn't hard, is it? Add, subtract, multiply. Okay, this is the one, division. If there's anything that's hard, it's this one. Now, I teach pre-calc sometimes, and when I teach it, it's amazing how many pre-calc students don't know how to divide polynomials. Watch this. F divided by g of x is the same as f of x divided by what? G of x. Put the functions in, and you get what? X squared plus x minus 6 over?
X minus 2.
Okay. And the question becomes how? How do you divide trinomials and binomials? Say again. Multiply by conjugate. If you had a radical down there, like square root of x or square root of something, yeah, you're right. But we don't. And the conjugate wouldn't get rid of x's.
Can you just cancel?
You cancel. What do you mean by that? Show me. Or tell me.
Because there's an x up top and there's an x on the bottom.
Okay,
so
this x cancel out.
Yeah, and then you could cancel the negative
The
2
2
on
and a
the bottom.
6. Oh, very, very common answer. Watch this. I want to show you something about addition, subtraction. Okay, if I have 6 plus 2 over, let me just say 6 plus 3, something like that. What's the answer on top? Over?
9.
Answer's 8/9, right? But you're telling me cancel the 6's, and the answer's 2/3, right? When we know it's 8/9. You can't do what you said, but that is so common that students do that all the time. You cannot cancel unless you have what going on? Multiplication. Now watch this, guys. If that was the problem, 6 times 2 and 6 times 3, what is 6 times 2? What is 6 times 3?
18.
And that reduces to what? Okay, but when it's multiplied, I can cancel them out. What's the answer? It works. It works when it's multiplication. So, how do I turn this problem that we have, where is it? Back here, I guess. How do I turn this problem into multiplication?
Multiply by the reciprocal.
No. How do you turn addition, subtraction into multiplication? We've been doing it all year. Hint. What? There you go. You gotta factor it. Factoring is turning addition, subtraction, into multiplication. Okay, let's do it. Okay, how do you factor a trinomial? Well, it's this times this, right? Give me some factors that would work here. Think it out.
2 and 3.
You have to go loop. Okay, say again, John.
2 and 3.
John says 2 times 3. Is that up there? No.
Well,
Yeah, you gotta tell me.
look,
I know, John. You gotta say it the way it has to be.
that would be x minus 2, x minus 3.
X minus 2, x minus 3. Is he right?
No.
No.
X,
X minus 2, X plus 3.
Okay. Now, is this right? Is negative 2 times 3 negative 6?
Yeah.
Yes. Is negative 2 plus 3 1?
Yeah.
It's right now. Okay. I think it's a book, isn't it? Okay. And the bottom, can you factor a binomial if it doesn't have a GCF in it? No GCF. It's not the difference of two perfect squares. This one's done. Okay. Now I thought I said you got to have multiplication over multiplication. I do have multiplication here. Where's the multiplication here?
it's multiplied by 1.
Yeah, it's basically this times 1. Tell me what cancels.
X minus 2.
X minus 2 with an x minus 2. They're gone. And the answer is
X plus 3.
x plus 3 over 1, which is really x plus 3 is the answer. Okay. Okay. So how do you do this division stuff? You factor the top, you factor the bottom, you cancel out whatever is the same. That's it. Now, hang on. We haven't talked about domain of any of this. So what's the domain of this? What can I actually put in?
All real numbers.
It is because it is. Look, what's the domain of this one? All reals, because you can square anything, you can add a number to any number. This is all reals. What about this one? What's the domain? What can you take 2 away from? Any number. All reals. So remember how the answer goes? The answer to multiplication would be the whatever these two groups share. They share what? Everything. So the answer is all reals. Domain of the multiplication would be all reals. So far everything looks like all reals, right? Careful. What's the domain of division?
Everything except for 0.
Everything except for 0. So you're saying everything, and then he says, except don't let x be 0, because that doesn't get an answer. He's close.
X has to be positive.
Okay, wait a minute. When you guys divide, look, come here, look up. When you guys divide it, do you realize the bottom of your fraction can never be what number? Can never be 0. Well, when will it be 0 down here? 2 minus 2, 0. You can't divide by 0. So you cannot let x be what? 2. Now Isaac, he kind of knew 0 wasn't supposed to be down here, so he just said don't let it be 0. No. Don't let x be 2, and that's the answer. So Isaac, you were close. Just don't let it be what? Don't let it be 2. Anything works except 2. You okay? Okay, do the next, flip the page or go to the next slide. And just on the very top it says to multiply the two functions. Don't do it. Do the division one because the division one is much tougher than multiply. Okay? I'll give you a head start. Like 1 minute. Go. Do the division one on the next page. There it is. right. Aaron, did you factor the top?
Yes.
What'd you get?
3x plus 1 into x minus
3x, he says 3x plus 1, x minus 4, he says. I'm going to check his answer out quick. What's 1 times negative 4? Negative 4. He got that right. The inner, outer is tricky here, guys. Be careful. That's 1x. That's negative 12x. He got it. Okay? That's what we have, negative 11x. That's correct. Over what? Did you factor the bottom? No, because you can't. There's no GCF. It's not the difference of two perfect squares, so you can't factor the bottom. So he's basically got a binomial times a binomial over a binomial. There's your multiplication that's going on. It's that times that and that times that. Out with what?
3x plus 1.
3x plus 1, 3x plus 1, out. Answer. X minus 4 is the answer. Annalise. Yes. Okay, now, quick. Here's the hard part. That part I'm not worried about. I think most of you, maybe all of you will get that right. Hard part, domain. The domain of division will be, once again, what was the domain up here? Can you square anything? Yeah, it's all real numbers. Okay, can you take anything times 3 and then add 1? Yeah, all real numbers. So if you guys look at it, what do they share? Everything. But the problem is, it's a division problem. It is all reals except x can't be what? 1/3. What did you say? 4. And you're saying negative 1/3. Okay, it's the denominator that cannot be 0, not the numerator. You can let that be 4. What's 4 minus 4?
0.
You get an answer. You just can't divide by 0. So let's go this way. When is this going to be 0? Well, you guys should just quick solve it. Slide the 1 over, divide by 3. Guess what? It will be 0 down here when x is negative 1/3. So you will say, all real numbers work except one number. What's that one number? Negative 1/3. Can't let x be negative 1/3. If you do, this problem doesn't work. But everything else gets an answer. All right. What do you think? Division is the hardest, if you ask me. Add, subtract, multiply is pretty straightforward. Okay. Now comes the thing you say you don't remember. Composite functions, you don't remember them? A function inside a function? Not all. Okay, composition of functions. It's a function inside a function. This is what it is. And yes, you did do them. You did do them back in September. You probably didn't like them in September. I think you're going to be better at it. Here, quick. Here's a quick example. Here's g of x. I'll just give you 7x. Here's f of x. I'll tell you it's 2x, okay? This is what a function inside a function looks like. You take a function g, and you put in it, what do you put in? You put that function, f of x goes in. Okay? This is what it looked like back in September. This is what we did. We said, take this number, whatever this number is, stick it in a g. Well, what's this number? What is f of x? It's what? 2x. So you replace f of x with what f of x equals. It equals 2x. Now, you take the function f of x and you stick it where? Into function what? G. Well, what's function g? 7 times x. So then you write 7 times x. But what's x?
2x.
You're not putting in a number, you're putting in an expression, 2x. So the final answer is 14x.
You said g equals 7x.
Well, what it is, okay, Adrian, hang on. Whatever is inside inside is the number you're plugging into G. Well, this is not a number. It's actually an expression. It's just 2x. So you put it in for f of x right there. You stick this 2x into this function G. Well, look at G. 7 times x. So this number must get plugged in for that x right there. 7 times 2x. That's what I wrote. 14x. Hey guys, what if there was like a plus 6 back here? Then you'd have to say 7 times 2x plus 6, which now makes the answer kind of a little longer, right? Okay. That's all this is, though. Okay, let's get started. Here, there. I'm not going to read it to you because I kind of went over it, but I will tell you this. I think this is pretty good. If you look here, it says G circle F. Do you know how many students get this wrong because you know what they think that little circle is? That open circle? They think that open circle is multiplication. If you see open circle, it's not. It's a composite function. It means this right here. G of f of x is what it means. And then they have a little 1 and a 2 here. Well, the 1 just means first you evaluate what? The function f of x. First do the f of x, then do the second thing. Use the answer for f of x as the input for g. That's what you do. So this is probably the best information up here. Please look at it, okay, as you're doing these problems, okay? All right, first one is right here. F of x is x minus 5. G of x is x squared. What is this going to be? Well, to me, I wouldn't write it like that. If I see that in my book today, I'm going like this. F of what? G of x, but it's not x, it's g of what? So they're actually giving you a number to plug in. So when they give you a number to plug in, we just plug them in. All right. Start where first?
Function G.
Inside the groupings. So start here. Okay. G of negative 3, well, G is right here. So you would say f of, well, that says x squared. So you're going to square this number, right, guys? So what's that? F of 9. So once you perform the inside function, then you get an answer, 9. Now you take the 9 and stick it into your function f. Or this way. Well, where's f? It's right here. This 9 would have to go in for that x. It would say what? 9 minus 5. Answer? 4 is the answer. So really, guys, you have to do a function how many times? Twice. You have to do g of negative 3, get an answer, 9, and then do f of 9 and get an answer, and you're done. That's all it is. It was that way in September. It's still that way in April. Hasn't changed. Okay. Would you please do this one without my help and see if you get it before me? Now do g of f of x, or sorry, g of f of negative 3. Start with the inside, f of negative 3. Okay, I put negative 3 into the function f, up there. It says x minus 5, so what am I going to write? Negative 3 minus 5, that's what it says. X minus 5, well, negative 3 minus 5. What's that answer, by the way? But it's not negative 8, it's the function g when we evaluate it at negative 8. Now I got to do it again. We got to do it twice. Now put the negative 8 in function g. Well, function g is right there, guys. Put it right here. What am I going to do to it? It says take x and do what? Square it. Will that be negative 8 squared? What's the answer? 64. That's the answer. Okay? You okay? Okay. This next one, I'm gonna ask you to do not the first one, but the second one, because the first one's just like these two. We're gonna try that second one. The second one says G of what?
G.
G of A. This time they're not telling you to put a number in, they're telling you to put a what in? A variable. So stick the variable into the function. And we're only working with function what? G. So we don't even have to look at X.
Function G equals 2.
So I put this number A into function G. Here goes. What does X get replaced with? A. X becomes A minus 2. All right, there's the answer. When I put A into the function G, I just get A minus 2. That's the answer. But, now wait a minute, I gotta do it again. Now take this number, this is just a number, put it where?
In it again.
Back in it again, yeah. Put it right here, right there. And in place of that X, I'm gonna put what?
A minus 2.
A minus 2. But it's followed by another minus 2 back here, right? So A minus 2 goes in for X, followed by another minus 2. Which makes it, my answer be what? A minus 4. Yep. There it is. So you have to work inside first, get an answer, take your answer, stick it in the outside function, get a final answer, and you're done. Really, I'm just making you do it twice. That's it. Okay. Now the next story problem, when you turn the page or next slide, it is a composite type of function problem. So let's read it and see if we can make sense of it. And here it is. It's about buying a gallon of paint, okay? It says the store is offering a 15% discount on what? All gallons of paint. So you go buy a gallon of paint at Menards and you get 15% off.
What a deal.
Good deal. I'll take it. Okay, the other thing it says, the manufacturer, whoever makes the paint, is offering a what? $3 rebate on each gallon of paint purchase. Okay, I know you guys don't go out and get rebates because that's more of an adult thing. Maybe you have, I don't know.
They're really useful in online ordering.
Okay, what's a rebate?
Get
Well,
money
you
back.
can mail it in and you can get some money back. I know that's one of the things you can do.
11% rebate.
And that's what it is. You said it perfect, John, because I wanted you to say the words, you have to mail it. So like when I go to Menards and I get 11% off, I get a rebate and I go, I write it out and I go, I just spent $85 at Menards. And then they go, you get 11% rebate back. So then I send it in. And whatever 11% is, they just send me a check in the mail. It's kind of cool. But when I go up to the counter, do I pay 100% for it?
Yes.
Yes, I pay 100%, and then guess what? I gotta wait how many weeks?
A couple.
More like 5, 6 weeks. Then I get a little check in the mail. So a rebate's cool, but you don't get it back for a while, like a month. And that's the only bad part about it. Okay?
It's like delayed savings.
Yeah, kinda. Yeah, you gotta wait. All right, you guys ready? Here's what they want you to do. They want you to write a function f of x, okay, f of x, to represent the price of a gallon of paint after the cash what? Discount. This is the one they're talking about, the 15% discount. So what would paint cost us if we went up and bought it? Remember the price of paint is what? X, but I'm gonna get 15% off. Now what do I pay? That's the question. What's the answer over here? What do I pay for the paint if I get 15%? 0.85?
Yes.
How would you get that?
It's 15% is 0.15. So you can just subtract that from 1, and then you get the percentage you have left, but you have to pay.
Okay, now, John said it a little differently than I wanted him to say. He said, take 0.15 away from 1. Here's my thought. If I go to the counter and I pay for that paint, no discount, I'm paying what percent? 100%. Well, guess what? They just gave me what percent off? 15% off, which means I pay what percent?
Good time being paint business.
I pay 85% or whatever that is. So to me, if that's the cost of the paint, X, I will pay how much? 85% of the cost of paint. Now I don't know what that number is. It could be 20 bucks, it could be 50 bucks, who knows? All right, that's the first function. Here's the second function, g of x. Write a function g of x to represent the price of a gallon of paint after they apply the $3. Oh, you know, and I wish they would have just said what? Rebate? I mean, I get what they're saying, but I like rebate better because then it tells you what is going on. So if X is the cost of paint, what did you actually pay for the paint?
It's just 0.85x minus 3.
No, get rid of the discount. We're not talking the discount.
X minus 3.
Yeah. Whatever the paint costs you, minus $3. That's what a rebate is. Just take off that number, and that's what you are paying for the paint. Okay? This rebate had nothing to do with percentages. Just it's your cost of your paint minus $3. Okay? So there's two things going on with your paint. You get a discount of 15%, and you get a rebate of $3. Okay, now read this. Suppose a listing price of a gallon of paint is how much? $45 for a gallon of paint. Okay. Use composite functions to find the price of a gallon of paint if the cash discount is applied before the rebate. So what was applied first, guys?
The $3 discount.
No,
Of X. F of X.
this is the percentage. This is the 15% off.
But it's
First take 15% off, then do the rebate. Well, that would be, what was the discount?
F of X.
That was f of x. Yep. So you should do this one first. Then on the outside, what was applied last? The rebate.
Please excuse this short interruption for a couple brief announcements. Girls soccer practice will be at 4 p.m. today at Lions Park at Central Elementary. See Coach Dubois if you have any questions. In girls softball, today's games have been postponed and practice will be at 4 o'clock in the small gym. Thank you.
Okay. You know that f of x right there? I put f of x, but I know the price of the paint. 45. So I could put a 45 right there. Okay? Now, do your inside function first. Put your 45 where? In for x, right there. So you would get 0.85 times 45. What am I paying for paint, guys, after the discount? Yeah, 85% of $45.
$38.25.
$38.25, okay. Okay, now the second thing that's going to happen to your price is you're going to take off a rebate. Well, that would be put it right in for G. So it's going to be what? $38.25 minus $3. You really only paid what?
$35.25.
Okay, good. Do the next one. Do this one. I believe it will be the opposite of what you just did. Probably F of G of 35.
85% of 40.
Okay, do it. See what you get. Put the 45 in the rebate function, take off $3. You paid 42 for the paint, right? Okay, now, put the 42 where? Into the other function. 0.85 times 42. Who's got the answer?
35.7.
35.7? $35.70. Got it. Got it.
Can you assign this for tomorrow or Wednesday?
Okay. You got it tomorrow? Really?
Yeah, that's so nice. I know.
Yeah.
I can listen. I'm not bored to death.
Yeah. Yeah, I'll put it on there, but you know,
I feel like I learned something
don't
today.
need to ask any questions. Okay, 4, 3, normal. 4, 2,
Yeah, we're going on. Thank you.
all right, you bet.
Just wait.
Oh, you can go in the math office. I mean, I'll be in there in 2 minutes. I gotta clean up a mess.
I just like.
Sorry.
Here is 6482. And
Hey,
I
did I?
I gave the option.
No, today's.
oh yeah,
And the odds
Did I tell everybody
were
this is
yeah.
No, the Oxford and the.
No, it's not here.
Sleeping.
6, 4, day 2. Okay.
You're doing that.
For what?
You're doing
Oh no. Oh no.
hello.
Hey.